All right. We are live. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. Pete's Astrophotography, good to see you. How have you been? Welcome to the stream. Hope you're doing all right. Apotham, good to see you as well. So we're doing a little something different tonight. We don't normally stream on Friday night, but I did miss Wednesday, so I'm doing a little bit of a makeup stream tonight. And I don't have necessarily huge plans, but I want to start kind of thinking about what we need to do for our animation system, because that's really the last feature that we need to get in place before we can kind of switch back to the game code for a while. And so I want to go ahead and think about that a little bit. Maybe make a to-do list of small bugs and items I need to clean up. But other than that, I think animation system is probably what we're going to start thinking about tonight. And I haven't really thought of that, too much in advance. I kind of want to step through the design with you guys live. So before we do any of that, though, I do want to take just a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Alazaran, followed by our partners, Gorbolis Inc., Magetsub, and Matt Oscard. They are the highest tiers of subscription over on YouTube memberships, Patreon, and Twitch subscriptions. Followed by our list of supporters here that are scrolling on the screen. They are a list of the combinations of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So I should mention that Tier 3 subscription on Twitch does equal partner status. So just to sort of clarify that. But all of these fine folks here are supporting the channel, and those funds go directly towards supporting the things that I do here. So things like software licenses, hosting fees, things of that nature. So thank you guys very much for that support. It is greatly appreciated and helps me out quite a bit. I really appreciate it. Speaking of appreciation, I do appreciate all of you viewers here, whether you're joining us on the YouTube side or the Twitch side live. Thank you guys for being here. Even if you're catching the VOD after the fact, I appreciate you guys as well. Thank you very much for being here, because without you guys, this project and this channel would not exist. All right, Ojor over on the YouTube side, hello. I hope I pronounced your name correctly. I tend to butcher names sometimes, so correct me if I'm wrong on that one, but hello. Hope you're doing well. All right, so in terms of the animation system, we've only really kind of done one little tiny part of that. And I kind of want to think about all the data that we have to store for that, and how we are going to set that up. And believe it or not, I think the last part of that we're going to tackle is going to be the portion of actually handling asset imports, right? Because I have a couple of ideas of things that I want to talk about in terms of that, but I don't want to sort of approach that until we figure out the usage code. So my idea for this is that we sort of plan out how we want our user code to look, and then we essentially round out our implementation based off of that, right? So just as a reminder of where we are currently, I'll just go ahead and run the application. And so if I load the default scene, we still have a couple of small issues here, right? But we do have the ability to sort of move around in space. We got our shadow mapping fixed. I did fix offline. I did fix the reflections, so those are now working as they should, as well as the refractions. So all of that stuff is fine. There's still an issue with the lighting, the directional lights that I have to figure out, but I don't really want to spend too much stream time sort of going through that. So I think I'm just going to kind of put that to rest for now, and we'll come back to it at a later date, or I'll just sort of silently fix it and move on, right? Because I think it's probably something just not being fed in correctly somewhere. So when we think about some of the things that we are displaying here, particularly static meshes, one of the things that we have is the vertex data for that, right? So our vertex data for static meshes contains things like your your positions, your normals, your texture coordinates, your binormals, your tangents, all that good stuff, right? And so our vertex data for animations is going to require two extra things. It's going to require bone data, or at least an index into bone data, or an array of bone data, and also a weight, right? And so if we take a look at the animation system in general, we already have our storage buffer here, right? And we actually already have access to this, like in all of our shaders as well. We will need to modify, I think we'll need to modify our animation shader a little bit, the vertex shader, to take some of this stuff into account. But for all intents and purposes, that is, it's pretty much, at least in terms of vertex formats, it is right where it needs to be. So, all right. So let's see. So we have our animation system state, and then we have our global SSBO data. So our global SSBO data right now is basically just a massive array of Mat4 stuff, right? Which is actually not what we're going to need. We need to define this a little bit better. So what we're going to do, I think, is we're going to have a typedef struct. And when we think about the animation data that we need to store in the shaders, which I think is probably going to be the first place that I'm going to start, so that we figure out, how we actually need to handle this data to get it to the GPU so that we can actually render it. We really need sets of animation data, right? And it's probably going to be nothing but Mat4s, but there may be other stuff we have to include. So I don't want to just say this. Obviously, this was just sort of a temporary thing that we came up with just to kind of get something in place and hooked up. So the structure I'm going to go with here is probably going to be, I guess we can call this animation bone data. I'm not 100% sold on that name. We might wind up changing it, but that's what we're going to go with for now. And then this is actually what is going to contain an array of Mat4s, right? So each bone in an animation is going to be represented by a matrix, right? So it's essentially going to have a transform of its own. So within an animation, you'll have a hierarchy of bones, and then each one of those bones are represented by a transform. Those transforms are obviously parented to one another, and then those transforms are actually what we have to include in here. The reason that we're not using the global transforms for this is because we don't necessarily want to pollute our global transforms with animation data, right? That's not necessary, at least not at this juncture, right? So we're going to call this bones. And instead of hard coding that, I think what we're going to do is we're going to define, whoops, if I can spell it correctly, we're going to define a K animation max bones. And I have 100 hard coded there, but I think that's kind of excessive. So I'm going to start off with a value of 64. And so what this is basically going to say is how many bones can a single animated mesh contain, right? And anywhere that we are going to use that, obviously we'll use this defined value here. And so if we need to change it later on, we always can. We're also going to define, we're going to say K animation, animation. And I think we might just go with, what do we want to call this? I guess we'll say max bone. Can't type tonight, apparently. Should we say weights or influences? Influences. Feel like it's kind of long. Let's do max vertex bone weights. And we're going to say 4. So what this value is going to be is this is going to be the max number of bones that can affect a single vertex, right? So the idea of an animation is you have these bones, at least for skeletal animation, right? You have these bones that have transforms, and those transforms affects vertices within the mesh, the animated mesh. And so you can have 64 of those, right? But there will be times where you want a particular vertex or set of vertices to be influenced by more than one bone. And so an example of this, I guess, would be something a little bit more complex, like a shoulder on a player mesh, right? It's going to be influenced sort of by maybe the collarbone that's up here, and maybe a transform for the upper arm, and maybe even the neck a little bit, right? Because, you know, as you move around a little bit, your shoulder kind of moves around with your body, right? And so there's multiple different things that can sort of affect one given point on your mesh. And so we're going to give that a max of 4 right now. I don't think we'll use 4 in most scenarios. But you know, we'll go ahead and we'll say the max number of bones that can affect a vertex is going to be 4, and the max number of bones that can be in an animation is going to be 64. And so what we'll do here is in our storage buffer for each animation bone data, we're going to say K animation max bones. And so all that this is going to actually have to hold at this particular level is just a list of the bones, right? So for each one of these animations, we are going to have you know, a list of bones. So in here, in the actual SSBO data, instead of having this, you know, mat4 stuff 100, we are going to have animation bone data, and we're going to have, let's see, we'll do animations, and we don't actually have a size for that yet. So let's define a max number of animations, right? So we can say K animations max, I guess we can say. And this will be the maximum number of animated meshes that we can actually have. I'm going to start off with a value that's kind of conservative on this, and I think I'm going to say just 100. Actually, I feel like that's probably even excessive. Maybe we'll start with something more like 50. And so we can always tweak this, you know, as necessary, or maybe we'll even expose this. You know what? Let's actually expose that as a configuration option. Let's actually do it that way. Because SSBOs, or storage buffers, can actually contain arrays, dynamic size arrays, at least for one member, at least the last member within that struct, right? So we're going to go with that. And let's see. I don't know. I don't feel like we actually have to include the number of animations in the storage buffer. I feel like we can just index into it and be okay. I don't feel any reason to actually include the max number in the SSBO data. Let's see. Better than most other streamers, so good enough on the pronunciation. Fair enough. Yeah, I appreciate that. Matrix Cats, how's it going? First time chatter, welcome. Hope you're doing well. I will apologize in advance if we kind of get into the groove of things tonight, and I don't keep up as well with chat as perhaps I should. I do try to bounce back and forth as much as possible, but sometimes I miss stuff. So feel free to call my attention to that if I do. Okay, so the animation system config. Then we sort of had this type def dummy in here, we're going to say max animations here. And so that max animations will be used to figure out how large this array is going to be. So in our system state, we'll go ahead and also keep U32 max animations. We'll just keep a copy of that. And then let me think. So we probably ought to. I'm actually thinking we probably ought to also have a little bit of a, for lack of a better term, a duplicated state. So we're going to have the state that's sort of held by the SSBO, right, which is both of these guys. And then we're also going to have a state that's actually held by the system that we can actually use to calculate hierarchy and all that kind of stuff, right? And so I think we probably ought to think a little bit about how, some of that stuff is stored. So let me think. How do I want to actually organize this? So I think there's going to be there's multiple levels to think about this on, right? There's the state of a particular animation, right, which tells us where the current bone transforms are and all that stuff. There's the shader data, which is sort of a separate state, right, a simplified state or a pre-calculated state, if you will, of that. And then there's the file format. And all of these things are going to have to store like data, but not necessarily the same data. So I think we'll make our file data fit loosely what we need to hold in our system state data. And then we'll make our system actually translate somehow. And maybe we'll even store our system state in such a way where we can just quickly upload to this guy. So I'm actually kind of thinking, so we have the animation bone data. Maybe we should actually just call this animation data. Right, because it's not actually specific to bones. It's actually just animations. So if we call this animation data, then we have bones in here. Which is just an array of bones. And maybe we call this animation, let's actually call this animation shader data. Right, we are going to have some sort of duplication here of data. So shader data. And then in our actual state itself, we'll actually have a separate struct that we're going to say typedef struct animation data. Data. Right, so this is going to start off having all of these bones, right? And then I'm actually thinking, do we have how do we want to store our hierarchy of bones? Right, because ultimately what we're going to want is we're going to want to be able to take from our animation data and very quickly jam that stuff into SSBO data, right? But we need a way to actually store the hierarchy between bones. So I think we ought to keep this as a flat array, the actual bone data as a flat array, and store the hierarchy separately, right? So maybe let's do a typedef joint, right? Or I guess we can say animation joint. Or do we want to say joint or bone? Let's go with bone. Animation bone. And let's have a U32 bone ID. and U32 parent bone ID. Right, this is a struct. Oops. And so maybe this is, maybe instead of bones, we call this transforms, right? In both cases. So we have transforms, and then we can just say bone transform ID, parent bone transform ID, right? Or do we actually need transform ID? Actually, I think we can get away with just bone ID. So we're going to have transforms here. Then we'll have animation bones, right? And animation bones is also going to be K animation max bones, right? And so our animation bone will actually store the hierarchy and a lookup into the transforms array. The transforms array, of course, is what will be uploaded to the shader and will ultimately be used by the shader. I think that makes sense. So we have those two. Parent bone ID, we're just going to make a note here and say invalid ID equals no parent, right? And so we have that, and then we should probably actually have the U32 bone count. And actually, now that I think about it, our state here doesn't necessarily have to, doesn't even have to work the same way. We can actually do, we can do dynamic arrays here and not have these be defined that way, right? These can be dynamic arrays. Because what's going to matter is when we go to upload those transforms, we just do a mem copy of, you know, bone count for transforms up to a max of K animation max bones. So this is going to be required by the shader, right? But we don't necessarily have that same thing going on here. Okay. So that will handle our hierarchy of bones. I think we could probably even do something where we could try to store the bones in like a breadth first order so that we could just sort of traverse the list from top to bottom and automatically have things in order as they should be. I don't know. We'll have to figure that part out. Okay, so we have our animation bones. What else are we going to need? So we're actually going to need, so this is animation data, which technically can be used for more than one animation, right? So how do I want to do this? We might want to say animation. So this is for an individual bone. This is for, how do I want to do this? Do I want to call this maybe animation skeleton data? Right? Because that sort of implies that this is for the structure of how the bones are related to one another. But then we also have something, another concept called keyframes. Animation keyframe. Keyframe. So keyframe essentially determines multiple bone transforms for a particular point in an animation, right? So ideally you would have something like you would have like a an animation that had several different keyframes for different poses within that animation, and you'd want to essentially tween between those. And so what you'd want to actually have in here for each animation keyframe is you would want to have a list of animation bones for that particular keyframe, what the timing of that keyframe is, and what those bone transforms should be, I'm thinking. So I guess we can just do F32 rather. And we'll do I want to do time? How do I want to call this? Yeah, I guess we can do time. Right, so this is going to be do we want to go by time or do we want to go by frames? If we go by frames, we could theoretically... I feel like we should go by times, actually. Because that's going to tell us how long an animation needs to scale between frame A and frame B, right? Yeah, okay. So we're going to say the time offset from 0, where this keyframe should be applied. Aqua NR over on the YouTube side, how's it going? Welcome. Hope you're doing well. Okay, so we need that. We need a list of bone IDs. So that's going to be U32 bone IDs. We probably also need a U32 bone count, right? And then there are two ways we could approach this. We could either store a matrix directly here, which would be 16 floats, right? We could store position, rotation, scale, and build a matrix off of that, which we'd probably have to do in runtime anyways, just to make it quicker as we're actually iterating. I feel like that's probably the better solution, actually, because if we think about, so rotation is going to be 4 floats, and then you have another 3 for position and another 3 for scale, right? So that's 10. So I mean, technically we are costing ourselves a little bit of memory by storing the end-all be-all matrix per keyframe, but we're going to have to generate that data anyway. I think I'm fine with it. I think I'm fine with that trade-off because that's going to simplify our code. So we're going to do transforms, right? So essentially we're going to say we have this many bones for this keyframe. Here's the IDs of those bones, and here's the transforms for those bones. And then essentially we would loop through and say, if we're on this keyframe, set the transforms of these bones to the transforms that we have here. And we would tween between this keyframe and the next keyframe. within the animation, right? So now we need somewhere to sort of store the keyframes, right? So we have, let's see, we have animation skeleton data, which is going to be our hierarchy, which I might call that hierarchy. I haven't decided yet. I feel like we need a new struct for this whole thing, right? So I think animation skeleton data is part of what we need. That's part of it, right? But we're going to do type def, and we'll do struct, and we'll say we need 2 levels here, actually. So we need something that kind of encapsulates all of the data for a given set of animations. And then we need animations themselves, which then contain sets of keyframes and a reference to the skeleton data, which can be reused between animations, right? So I guess let's call this, animation data. Oops, data. Right? And so in this, we're going to have the animation skeleton data. And that's going to be, we'll just call it the skeleton, I guess, for now. And then we'll also have animations, right? So we're going to have type def animation, and the animation is going to have a K-name, and it's going to have a set of animation keyframes, right, with a count. Keyframe count. And it'll probably contain some other stuff too. Let's struct. And then our animation data will have animations, right? And we can even have a animation count, U32, right? So this is kind of going to be the main thing that our animation state holds on to, right? So we'll have, and I don't know that animation data is what I want to call it yet. We'll have to do some thinking about that. But animation data is essentially sort of the container that encapsulates all of the data for a particular set of animations, right? And within that, we have how many animations we have, and then the skeleton that's associated with that, right? So these animations apply to this skeleton. And then within the animations themselves, each animation has a name and keyframe count and keyframes. I suppose we could probably actually... no, I think that's fine. I think that makes sense, right? And then, of course, keyframes have the transforms and the bone IDs and all of that stuff too, as to how to actually apply that stuff. And so if you need to tween between two particular animation frames, or keyframes rather, you would access it through that. Let me see, we're going to catch up on chat here. Singy, good to see you. How's it going? Welcome. Let's see. Hello, I have no context on anything on this. So what exactly are you doing? So we are designing our animation system for skeletal animations. And perhaps we should maybe even call it that instead of just animation system. Maybe it's skeletal animation system. I haven't really decided that yet, right? We're still kind of figuring out names. So what we're doing right now is we're kind of figuring out what data we need, how that data should be laid out, both at the shader level and at the system level, because we have to think about how we're actually going to handle these animations in terms of the system data, and then what needs to actually be uploaded to the shader so that the shader can actually interpret these animations as it should. And so the shader data is actually going to be remarkably simple, right? It's just going to be a list of transforms. And the animation system is basically going to be responsible for providing for each of those animations a set of transforms for that particular frame. Okay. You're looking for the the greater context. So you're making an engine or working on a game itself, both. So here, let me back up just for a second here and do. So what we're working on is something called the Kohi engine. I'll drop a link here in chat. And essentially what this is a game engine written from scratch in C using Vulkan as its initial rendering backend. And so this initially started off as sort of a tutorial type series. And obviously something the size of a game engine, you can't remain in that format forever. It just doesn't work after a while. So we kind of moved on from that format, and now we're doing sort of a live stream format where we talk through all the designs of the stuff and sort of come up with everything sort of ad hoc on stream. It's designed to be an educational resource on a way to build a game engine. It's not the only way to build a game engine. A lot of times it's not even the right way to build a game engine. We do a lot of experimentation on here. And so I say when it's not the right way, right? It's not what might be considered the industry standard, for lack of a better term, because we want to try different things on here to see what works, what doesn't work, and why in each direction. And so we do lots of trial and error on here just to kind of get a feel for what works and what doesn't. And so we do simulcast to YouTube and Twitch. The engine itself is available on GitHub. So if you scroll to the bottom of this page, there is a GitHub link here, along with Discord, which has got about 1,000 members on it, and a Patreon link because I don't have any sponsors or anything like that, right? And so the whole idea behind this is this is an educational resource. So the game engine source itself will always be free and open source. Because it's an educational kind of thing, I believe that kind of stuff should be free. So it's never going to be paywalled of any kind. There's never going to be any licensing fees or royalties of any kind. It's Apache 2.0 licensed, which means that you're free to use it for whatever you want, whether that be personal or commercial. The only thing that I ask is that if you use it, you just say you used it. That's literally it. Just somewhere put that you used it, right? And so, this is, relatively early days, right? It's not something that I would ship a production product on yet, right? Because we are still very much building pieces of it. That being said, we have actually started developing a game for this. And so the plan is that we are going to run the engine through its paces by building a game and shipping a game on it. So we're going to build a game all the way through release, and we're going to release a game on Steam using this game engine. And that's going to be the way that we sort of exercise the engine along the way. And so the idea is that we're basically going to use the game to identify pain points along the way, so that we can fix those things. And we've already started on that. We've already identified some pain points, and we're like, you know what, we really need an animation system. That was one of the last major things that we're going to need for the game that we're going to create. And so that's kind of the idea behind that. I've got a couple of dated screenshots here, just kind of showing some of the features and stuff, but nothing really too important. We've got a basic PBR pipeline, the ability to select and move objects around the scene, although we're going to be rewriting a lot of that logic for our actual game-specific stuff, right? But we've got, everything is here in terms of setting that up. Right now, this is best served as a sort of example on how to do various things within a game engine. I would not, like I said, use this in production just yet. It's not really ready for it. But I hope that sort of gives you an idea of what we're working on. Fan of Vulkan and C because I'm a Linux user, so native support is nice. Yeah, I'm actually on Linux right now. Arch, by the way. Roman General, good to see you as well. Hope you're doing well. Let's see. Asked you about a terminal and you said Wes terms some time ago. I switched to it. Yeah, it's pretty good. I'm still using it, actually. Yep. It's fast. It works well. I haven't had any issues with it in terms of application compatibility. Usually the litmus test for that is Vim, actually. So, let's see. I'm stumped. My make files all of a sudden decided to start compiling my Windows code as if I was using Linux, which obviously isn't working. Oof. That's suboptimal for sure. Yeah, no, I've got some OS detection code and the make files for this if you want to use it as a reference. Do you already have a way to read animation file formats, or that's coming up? I mean, third-party formats. So, we haven't really talked about that yet, right? I guess I can kind of go over what I'm thinking. So, thus far for our static meshes, we just use OBJs, right? Which is okay, but we wanted to experiment and go through the process of writing a parser for that. That was the reason I chose that format, and that's why we've done that so far. However, the industry standard, if you will, for importing these types of assets is to use something like ASIMP, right? And so my plan here is, when I say that we use as few libraries and dependencies as possible, that's for the runtime, right? So we're not going to use a library like ASIMP in our runtime. The plan is to use something like that in our import framework, which is externalized from the engine. So my plan for this is to actually use ASIMP to import these animations and extract the animation data out of it. We could write this stuff from scratch, right? I've looked into writing a Collada parser, for example, and I've looked into writing a parser for GLTF and that kind of thing. Frankly, I don't think there's a point. Those are solved problems. I think that's an acceptable use of a third-party library. We're not going to integrate it into our core engine code. It's purely going to go in our tool set, which means if you wanted to use this engine, you don't necessarily have to do that. You could write your own importer, right? So we are going to set up our own custom proprietary format for animations. And we are going to essentially use their importer to import to that format. And then our engine will be able to load that lightning fast because it's already in a format that the engine expects and is designed to work with. So we're kind of building this in a little bit of a backwards way, where I'm defining how it needs to be represented in the system in the end, and how we're actually going to feed that data to the shaders. And we're kind of handling that aspect of it first. And then we're going to go back and say, okay, once we have those things in place, maybe with a couple of hard-coded tests, just to ensure it kind of works, then we'll go ahead and worry about loading from a file, right? And we'll test it using various different test assets that I can find around the internet or something. And then once we have that, we'll have an entire solution. So I think it makes the most sense to sort of design this thinking about the usage code first. And so the usage code that's probably most important here is going to be how it's represented on the GPU. And then you've got the user code perspective, which is how the game code is actually going to switch between this stuff, which is something we haven't talked about yet, but we're going to talk about tonight. So that's kind of the plan. I hope that makes sense. You're on Arch too? Awesome. Yeah, I actually, I named my machine Arch BTW just for the memes, but yeah, I am actually using Arch. Okay. Okay, I think I caught up on chat. Yeah, perfect. Let's see. Thank you for the follow, by the way. I did miss that one, but okay, cool. Makes a lot of sense. Thanks. Okay, cool. So yeah, that's kind of the approach here that we're taking to this, which is a little bit different than how we've done some other systems, but this is a little bit, there's a lot of data manipulation that has to happen here. So we have to think about it from multiple fronts. We'll try to get it right on the first pass. Chances are there are going to be things that we're going to have to rethink, but I'm going to try to avoid that anywhere I can. All right, so we have animation data. Do I really want to call it that, though? I don't love that name because that's kind of nebulous when we talk about animations, right? Maybe we say animation. Do I want to say animation set data? I can't think of a name. Naming stuff sucks. I struggle with that, I swear, more than actually writing the code itself sometimes. Do we want to do animation collection? I don't really like that either. It's sort of a container, right, for animations and the skeletal data. Note that this does not include the mesh data. That's something entirely different that's going to be managed separately. This only includes the bones and the animations, the timings, all that stuff. So I guess I can stick with animation data. I really don't love this name. I'm going to put a fix me in here. In fact, rename this to be something more descriptive of holding multiple animations and or as well as skeletal data, not storing mesh data. That will be handled in the skinned mesh system, which we do actually have scaffolded as well. I suppose we could say, no, I don't know. I'm not going to think about it anymore for right now. Okay, so what we want the ability to do is for each animation, we want the ability to play that animation, stop that animation, pause it, skip to a particular part of that animation, play the animation at a certain point in time within the entire scope of the animation. So let's say by percentage. And then we also are going to need the concept of blended animations, which I don't know if I want to get into right now. I feel like we need to get the basics working first, and then we can worry about blended animations. Blended animations meaning that we can have more than one animation playing at once, and we can blend or essentially interpolate between the two to get a sort of result that's in between. Right, so one example of this is you may have a running animation, right, where the legs on your character are running, and then you might also have so the animation of the legs running, right, is something that constantly runs in constant time. But then you may also have an animation, and this would be for like a first-person shooter, right, of like them. Like the character's upper body holding a gun, right? And being able to aim up and down, right? Which is a separate animation, right? And so you would need the ability, when I talk about blended animations, you would need the ability to be running and then also be able to separately add that sort of animation going like this, right? And so you would use a blended animation for that. And so that's kind of an example of what we might have there. Or maybe a running and attack, right? Like swinging a sword or something. That's the kind of stuff I'm talking about when I talk about blended animations. And those animations could play at different rates, or be connected to different things. Like the player looking up and down would be, based off of their camera angle, for example, right? So that's where you would want to be able to shoot to, say, here would be, or I guess looking down would be, 0% of the animation, and looking all the way straight up would be 100% of the animation. That's where you'd want to essentially interpolate that based on the angle that you're actually looking at, that kind of stuff. So we need support for all of that kind of stuff. I don't know how much of that we're going to use right away, but it is stuff that I don't want to sort of leave out, because you want to design for that. This is one of those things you want to kind of design for everything you might need from the get-go versus having to try and work it in later. Good old slurp, exactly. Yep. So a lot of examples of animation systems that I've seen will actually store in our keyframe data. They'll actually store like the quaternion separate from the position, but we also need to interpolate scale as well. So I think it makes sense for us to just sort of pre-bake that and not store them separately. Maybe that'll change. I don't know. Okay, so for each animation data, we have the animation count, we have the list of animations in the skeletal data. We are also going to need to store. This is sort of the base data, right? So the skeleton stores sort of what the base transforms are for all of the bones. The animations store keyframes, which all have the different poses, right? So you have all of that, which is great. But then we also need to store on top of that. We also need to store all of the resulting transforms of any animations that are playing, and what all those bone positions would be. And then that is what winds up getting sent to the shader, that list of transforms. So while we have, the skeleton data here that has our bones in it, that in turn has, our bone IDs that we can then look up in our transforms, blah, blah, blah. We are actually going to need an additional thing in here. And I think I'm just going to put mat 4. And we're going to do... How do I want to say this? Do we want to say... I guess this would be world transforms? Or bone transforms? And then this will also have to have a U32 bone count. Right, and then this, oops, actually, this is what gets sent to the storage buffer and used in the shader, right? So these transforms are ultimately what are going to affect the vertices. And we want to store a copy of that here, A, for debugging, but also because we can just very quickly take this and do a straight copy to the storage buffer. So I feel like I'm missing something here. Yes, I am missing something. So we probably ought to also have some sort of animation state within this. Maybe that's what... So an animation state would go with an animation, right? It would go right alongside an animation, essentially. And that would tell us things like, let's actually type def this real quick. Right, so an animation state would have like an F32, and I suppose we could go with a T, right, on this, and that could be the, 0 to 1 progress through the animation, right? Or something like that, right? I don't know if I want to use, again, this comes back to, do we want to interpolate based off of overall time? I guess it would be time. And then we'd have to figure out how to translate that time into animation keyframes to say, okay, for this period in time, what 2 keyframes surround it? So I guess we can figure that out in yeah, that should be fine. Okay. So then we also have animation states, right, that hold the time. And then also, let's see, should we just align each of those states to each of the animations and then say whether or not it's active? Or do we just push things into this array when they're active? Right? Maybe that's the way we should do it. So we'll say active, or I guess we'll say states for active animations, right? Because we can have multiple animations active at once. We will do U32 active anim count, right? And then this will be active anim states. Maybe we'll call that, right? And so this is kind of what we'll use for blending of animations as well, right? So we can say, I want to activate this particular animation, and then, we just sort of progress through that particular animation. The other thing is, we probably are going to need a way to describe in the animation what the total time is. So F32 total time, right? And so that'll be, time in seconds for the entire animation to play. And then that we can use to figure out our keyframes, or what our active keyframes are. And then our animation states, this will essentially be current maybe we should have this be current time, right? Which translates to, we could use that to translate to a 0 to 1 animation progress, right? I feel like that makes sense. Thank you for the posture check, Redeem. I can feel it in my back, actually. I was, must have been sitting weird for a while. Bone count is repeated, by the way. It's already in skeleton data. Oh, you're right. It is. Oh, right. So there are different things, right? So our skeleton data, this is sort of our, we'll say our default transforms of the skeleton and its bones, right? Versus this down here is actually sort of the active states of all the bone transforms, which I guess technically means we don't really need to define this in two places. We could theoretically just pull. We could just have one count. Yeah, so one's the rest position versus the runtime position. Yeah, they're different states, but the count will technically be the same, so you're not wrong. Yeah, I feel like we could probably just counts are based on the animation data bone count. I think that makes sense. Yeah, because that is better than storing it in two places. I don't disagree. But yeah, one's sort of the active state for it versus the default pose state for it, the T pose, if you will. Let's see. First time chatter, Graphite Master, welcome. Hi, new here, just came across this. You may also want per bone masks when if you do blends, so you can mix upper and lower body animations. Also notice there's no separation of root motion for locomotion, but don't know what features you actually want. So both of those are good points, actually. I'm not going to go too crazy with this, right? I'm actually thinking we're going to keep this relatively simple. I think in terms of like blended animations, I don't see us doing maybe 3 at a time, absolute max. I'm going to say 2 is probably going to be even somewhat rare. 1 is going to be the most common for blending. Yeah, and that's one thing I'm trying to determine too is scope, right? Because this is essentially, it's just a 3D action RPG, right? So it's a 3D isometric action RPG. So it's not something that has to go crazy on the blended animations. So I don't think we're going to need anything too crazy. I think as far as the masks is an interesting idea, and I see where you're going with that. I might go that route, but what I was initially thinking of... Oh, I see your point, though. Right, because, for example, if you have a running animation and then you want to attack, you would want some way to make sure that maybe the upper body does like a sword swing or something instead of the typical arm swing that you would have when you're running. And so you would want a way to be able to say which one you want to prefer. Oh, that's a good point. Shoot. I hadn't thought about that. I'm glad you brought that up. All right, so how do I want to do this then? So in an animation, I'm thinking that needs to be part of the actual animation data itself. It's not going to be part of... Yeah, that's going to have to be part of the actual animation. So in the animations where we are defining our keyframes, where we define like what our bone IDs and our transforms are. That, I think, is where we're going to have to actually define the masks. Do I want to use masks, or do I want to use like a priority system? Where maybe one prioritizes over the other. There may be situations where I want them to blend with equal priority, in which case I would just multiply them together. But in the case of... That's what I'll do, actually. I could use a priority system, I guess. So I could apply some sort of priority that says the higher the priority, that's the animation keyframe that I'm going to take to apply. If you have two keyframes that are applying at the same time, or yeah, if you have two different keyframes from two different animations that are trying to apply at the same time, and one has higher priority than the other, then we'll take the higher priority one. If their priorities are equal, then we'll say that is, we'll just average them together, I guess. Yeah, I'm thinking that is a really, really solid point. But I also agree with you, Psycode. I think I'm going to get this working just kind of the basic mode and then add that later if I need it. So I'm going to put a to-do in here, and I'm going to say set up an animation priority. God, I can't type tonight. Priority, where keyframes playing at the same time would be checked for this priority. And the one with the higher priority would be the one that plays. Equal priorities equal priorities would average between them. I think that makes sense. Layer system with priority works, but it's definitely more complex. A simpler approach is just a parallel array of float weights indexed by the bone index. Just need to propagate the weight down the hierarchy when you apply. Oh, yeah, I suppose. Yeah, I could put that in here too. System of weights propagates. I can never remember how to spell that word. Propagates down the hierarchy. And is used to actually, you know what? That it does make a whole lot more sense than a priority. It's kind of the same thing, except you don't have the branching. Yeah, you're right. You are correct. Set up a weighted system that propagates down the hierarchy. And affects how much each keyframe is applied per bone. This automatically blends them together as needed, but avoids branching. Parallel array per bone per index. Wait. Parallel array per bone index per animation. Each entry is the weight for that specific keyframe for the bone. Yes. That's kind of what I had in mind. Yeah. And the count of the parallel array to tell you how many animations are running at the same time. Yeah, which is what I was kind of thinking with... Where was that? This, right here. Although I suppose this could just index into that or something instead of... Yeah, you know what, Graphite Master? I'm going to take that as a note. I'm literally just going to paste it in my comment. And I'll come back to that. Because, yeah, for now, like I am going to have this, but for now I'm going to keep it. Whoops. Dang it. There we go. So, yeah, I'm going to come back to that, but that is definitely something I want to support. So I think I'm going to take this in bite-sized pieces and kind of keep it simple first, get it working, and then we'll go back and add stuff like that. But yeah, that makes a lot of sense. Thank you for that. Appreciate the coffee emote, by the way. Is Arch noob friendly in 2025? That depends on how much of a noob you are to Linux in general. It's certainly a lot easier to install because they have the Arch install script, right? So that definitely helps a lot. But if you've not used Linux before, I do not recommend you start an Arch. I would start off with something more user-friendly like Mint or Ubuntu or something like that. And how much time you can sink into it. Yeah, that too. Boy, have I sunk a lot of time into getting Arch the way that I want it. But now that I have it, I could just kind of throw my dot files into a backup somewhere. And if I have to reinstall, it's not that hard. Which, as you may recall, a few months ago I had to do because I had an SSD die. So that was fun. But it kind of proved my point. All right. Now that I have it, I'm trying out Gentoo. You know, it's funny. I've wanted to try Gentoo. I'm like, do I have the time for that? I don't know. I don't know. Maybe one of these days, right? But this is also sort of my main setup that I daily drive every day. So I'm like, I don't know if I want to mess with it either. Why did what die? You mean the SSD? I have no idea. So, I was just using it one day, right? And I had a warning sign. In retrospect, it was a warning sign, but I didn't realize that's what it was at the time. I had booted my machine, and it didn't show up in the BIOS. And I'm like, oh, that's weird. And then I restarted the machine, and it showed up. So I was like, okay, I didn't think anything of it. A few days later, it happened again. And I was like, that's weird. Okay. I wonder why that's starting to happen. But again, I rebooted, and it came back, so I didn't think anything of it. And then I got a couple more days out of it. And then all of a sudden, I went to go boot up my machine, and it didn't show up. And reboots didn't fix it. And I'm talking, I tried rebooting probably 100 times. Literally 100 times. And it just would not come back. This is actually it right here. Dead as a doornail. I'm still keeping it in the hopes that I can maybe get it back working on another machine. I had most of my stuff backed up on it, but yeah, that was super annoying. So unfortunately, that had my Arch install on it, which was really annoying. So I had to switch even on the stream, I had to switch back to Windows for a couple days. Because I dual boot this machine, so at least it wasn't completely down, but still super annoying. But yeah, now I basically operate as if the SSD is going to die the very next time I boot the machine. Because, I mean, I learned my lessons about data backups years ago, right? But it still sucks to have to reinstall your OS. It takes a lot of time, and and whatnot. But anyway, that's where we are. So it happens. So anytime, I guess PSA, anytime you have it where even if you boot up once and your SSD does not show up, if you reboot and that thing shows up, back your stuff up because it's probably going to die. Because I did a lot of research online after that, and a lot of people had reported the same thing. Had an Arch install from 2008. I moved to a system until 2020, and I finally retired it, and I had to learn the awful Arch install scripts. Back then, you had the Arch install framework. Okay. See, I haven't been using Arch that long. I started using Arch 3 years ago, 4 years ago, something like that. But yeah, I switched to it and never kind of looked back. So, Jeet over on the YouTube side, how's it going? Good to see you. How are you doing? Hope you're doing well. Somewhat solved my makefile problem. Apparently passing an obj directory from the bat file breaks the makefile detection code. Really? Glad meeting you, Gramps. That's funny. All right. So the other thing that I kind of want to think about is something that a lot of our other systems are doing now, where we don't pass around pointers to things directly. We sort of have this handle that we use so that we don't have to worry about lifetimes and all that stuff. And our code crashing if we pass the wrong thing or do something stupid, right? Something with safe fallbacks that we can rely on, if we do something wrong. So I want to do a type def, and I'm going to say U16 for this one, and we're going to do a K animation, right? And so that's going to be an index into this animations array, right? So whenever we talk about a K animation, this is what the rest of the engine is going to interface with. So anytime we reference this animation or an animation, we're going to reference it using this K animation. And then we'll also do a define K animation invalid. Invalid. And we're going to say invalid ID U16. Right? And so everything that we do with that is going to work through one of those handles. So if we start thinking about how we want to use this, we're going to need a few different things. We are going to need... I'm actually not even going to think about creation right now. I'm just going to think about what our user code is going to need to interact with, right? So we're going to have basic things like, I guess I'll just say void animation. How do I want to do this? So I guess we could say, oh shoot. This comes back to the naming issue. So we have animations, right? But then we have animations within animations. Do we maybe call the animations internally tracks? Kind of like you would see on like a dope sheet, right? Because we've got this animation data, right? This is ultimately the thing that we want to index, right? And then within that, we want to play a named animation. So here in fact, let me actually put this in here. So we'll do animation data, and we're going to say, what do we want to say? Animation track. So maybe we'll say animations here, and then this we'll rename to animation track. I think that makes, oops, I need to do it here too. I think that makes a lot more sense. Okay, that just didn't work for some reason. Cool. So we'll do tracks. Right, that makes it a little bit more explicit. So we have our animation data here. The animation data is what is going to be referenced by this. So references and animation data in the system. Right? And so when we can say something like void animation play, track, right?
Dingus.
And we can do animation system states, states, and then we can do K animation, and then K name track name, right? Or maybe we go by index. I don't know. We'll have to figure that out. But I think that's kind of a reasonable thing to do, right? We could say play track. And then there are two ways we could handle like looping animations. We could, in the track configuration, set it up to loop, right, as a looping animations, or we could say when we play the track whether or not to loop it. I tend to think the second is a little bit more flexible, right? So we could just say, B8 loop as to whether or not we want to loop the animation. Track, clip, bank, all very common for this naming problem. Bank is used almost entirely in game audio for this problem. I have heard of audio banks. Yeah, that does make sense. But yeah, when I think of like, so clip to me is more like a video thing. Track to me is also kind of audio, but also animations, I think. At least that's what I think in my head when I think of like keyframes on multiple tracks and all that stuff, right? Like, I think that makes sense. Let's see. Yeah, so Potham, that's really weird about the objector breaking your makefile detection code. That's very strange. Using a whole 2 bytes for handles. Back in my day, we only had 2 bits to represent handles. Yeah, I was on the fence. I'm like, I could do this, right? But then I was like, I could definitely see us having more than 255 animations, potentially. Because I'm just thinking about like all the... you know what? Seems a bit wasteful though, doesn't it? We'll step it up if we need to. Because you're right, that does seem a little bit wasteful. Not completely disagreeing with that. Yeah. I mean, it's not like a huge issue, right? But like, do we really need 255 animations, right? Like, we lose one slot all the way at the end because of this invalid ID, which is fine. But yeah, I don't... Because when I think about it, there are certain things that aren't going to... that other types of animations that aren't going to use this system, right? Which is probably... we should probably also rethink how we're actually going to handle or name this system. Because technically, this is just for skeletal animations, right? We're going to have other types of animations that are going to occur that don't necessarily have skeletons associated with it. Things that I'm thinking of would be like billboard animations, like grass swaying in the wind or something like that. You wouldn't want to use this for that. Yeah, that's what I'm saying. I don't think we have the need for that many animations, actually. So I think a U8 will be fine for the handle. unless I wanted to go completely bananas with like the amount of different enemies on the screen at one time, but like really, I don't think that's going to be needed. So yeah, I don't think we're going to have a lot of that. And truthfully, we'll probably wind up trimming this down somewhat as well. Anyway, so we're going to have, we're going to need to play an animation track. We're going to need to pause the track, right? Animation, system state, K animation. And then K name, track name. Now I'm actually kind of, the way that, now that I'm looking at this, like I don't know if I want to go with names for this. Or if I just want to go with track IDs, animation, like by number. Because if I went with that, I don't have to look up a name. Right? We could literally just do that. And then if I need to name it somehow, I can just name it in the user code, right? So we have animation stop track. Oh my God. There we go. And that's basically going to be the same thing as this. The difference between play and pause will be kind of like most audio systems or video systems. If you hit pause, it'll kind of retain the position of that animation, versus hitting stop will actually stop it and reset the time all the way back to the beginning. And then we're also going to do, we're going to need to do an animation set time, right? Or I guess we're going to do set track time, right? And so this is going to be a F32 time. And that's going to be a relative track time to the animation itself, right? So if the animation is 2 seconds long and you set it to 1.0 here, you're going to be halfway through the animation. And again, the reason that you'd want this is so that you can manually interpolate that based off of some other value, if you wanted to do that. And then I guess it also might make sense maybe to have like a track percent, right? Where this will be percent, 0 to 1 type of thing. So 0 to 1 versus 0 to total animation track time. Something like that. Let's see. Some animations are meant to loop. I didn't see you keeping track of that anywhere. I'm not yet. Yeah, I was just trying to think about in what circumstance do we want, like, I guess what should our user code look like? And then we'll figure out how to store it, right? Because it really matters on, where we store this matters on how it's actually going to be used. I'm thinking we could probably have something in the animation track itself. Just a simple, like that, right? Is looping. And so that would default to false unless you play an animation that is set to loop. And all that would do is basically just keep resetting the time to 0 every time we loop around. Would have called that seek. Yeah, that's a good point, actually. Yeah, because that's actually a better name for it. You're right. I'm telling you, I suck at naming stuff sometimes. Um, so yeah, I guess this would be, you know what? We're doing this wrong. We should probably do, right? We should probably do that. So track play, track pause, track stop, track seek. And then I guess we could do track seek percent, I guess, right? True programmer sucks at naming things. Graphite Master is clearly an alien. Hey, I'm okay with that, right? Yeah, because I hate calling things get and set. I can't stand it. Because I think there's like 30 definitions of the word get or something like that. It's really ridiculous. It's such a nebulous term. Okay. So yeah, I guess seek and seek percent, I guess, makes sense. So I think that this would make more sense, or the most sense, for things that you just constantly want to have control over how it plays, right? Versus play is just kind of an automatic thing that it just plays at its speed, whatever. Oh, speaking of speed, that's another point. Animation track speed. I feel like set is actually kind of needed here, though, right? Animation system states. Okay, animation. I didn't type animation for any of those. U8 track. How did I miss that? There we go. And then F32 speed, right? So 1.0 is normal, 2.0 is double speed, etc. Let's see. I always scold people at work for get set. Worst part of get is that get has a side effect in the real world. If I get money out of an ATM machine, there's less money in my account. I'd love it if it weren't that way. Yeah, wouldn't we all, right? Yeah, I guess it would be playback speed, I guess. But like, this is one of those situations where we are setting something, right? But yeah, I agree. Like, I try to avoid the term get unless there's really no other. I mean, I suppose you could leave the word off, right? But like, that sometimes isn't descriptive enough. So yeah, we'll need playback speed because there are going to be times where we're going to want to modify that for sure. The other thing that I want, and this is actually going to be outside of the context of tracks, and this is something I found very useful in the past when I've written stuff like this. Animation system timescale. So this is like a global timescale that we can set. F32 timescale. And so basically what this means is it'll default to 1.0, which means normal. But this essentially is a multiplier for everything that goes on within the entire system. And so setting this to 0.5 would cause all animations across the system to play at 0.5. And timescale is something that we're going to want to implement and use regularly, especially in our debugging tools, because we're going to have things that happen very fast visually, and we're going to need to debug those, and we're going to need to slow them down, right? So the ability to set that time scale in here is going to be very important. Getters, setters, Java, Lombok nightmares. Yeah, exactly. I know what you mean. Yep. Change is also a fine word. Sometimes I use that in place of set when I'm stuck. Yeah, that's true. Update is also a common one. Yeah, I use update a lot. Update, though, is... I mean, I guess, like, in this case, like, I could say update, but that feels a little bit weird for this, because it is something that we are explicitly setting. It's not really a... I don't know. You know, it's one of those things that's a little bit nebulous, right? Like, set would work here as well, but it's... I'm not huge on that either. Thank you for the follow, by the way. Appreciate that. Welcome. Your suggestion to learn C through building out a string lib was excellent. Yeah, it's one of the ways that I feel like is a really good way to get a tackle or to get a hold on the language, for sure. Jeet, I am great. Thank you for asking. I appreciate that. I realize that answer is a little bit late. Worst part is getters and setters usually only differ by a single letter. Yeah, exactly. And it's very easy to get those backwards. And then you're like, oh, why does my stuff not work the way I expect? Especially if you have dyslexia. That can be evil sometimes. Thank you for the follow as well. Fully solve the passing in object dir from the bat files. Helps if you don't go dingus and actually set the variable correctly. Still weird that it broke the platform detection code. Yeah. Apotham, did you do some dingus oriented programming? And yes, it can count if you're doing make files as well. It's still writing code, kind of, sorta, right? You can do dingus oriented programming there. I don't make the rules. All right, I made the rule about that, but, you know, it is what it is. Slowly loving while hating void pointers now. Yeah. I used to use them a lot more liberally than I do these days. I try to use... I try to do this, right? And just forward declare some type. Even if I don't declare that type anywhere where it's publicly accessible, that to me is a better solution for most things. The only place that I generally use void pointers now is for like something that's got to be generic that handles multiple different types of things, like uploading data to the GPU, that kind of thing. So yeah, I try to steer clear of that as well. Was revamping my text rendering to use multi-channel SDF today. Was surprisingly easy and painless. That's always nice when that happens, right? It's always super nice when that happens. I mean, I guess I could just do this, right? I don't think I ever really have a need to actually get those values. I think I just need to set it. I think whatever uses this should probably just cache that wherever it's needed. Okay, so we have a global timescale, play, pause, stop, seek percentage, and playback speed. Trying to think if there's anything else I need. I don't think there is. Nope, I don't think there is. Okay, so as far as the individual tracks go, that is good enough. So what I think I'm going to do now is I'm going to come in here and do a K animation, and we're going to do animation create. And what I'm going to do here is, before I do that, actually, I need to type def struct, and I'm going to call this animation config, right? And I'm just going to put some, I don't know, U32 dummy in here for a minute. We'll come back and fill that out in a minute. Animation config. Right, and then I can come down here and do animation system state, and then we'll do animation config. Sure. You know what? I suspect that that is going to wind up being kind of a large struct, so let's just make a, let's just do a constant pointer to that. So that's going to be the creation, and then of course we'll have animation destroy, where we have a animation system state, and then K animation. The other thing that we're going to need is we're going to need some sort of hook into the update system. So I think this is fine to hook into just the standard update loop. I don't think we need to have a frame prepare on this, although we could separate that out. Yeah, maybe we should separate that out. All right, so let's do a void return type, and we're going to say animation system updates. And that's going to need the animation system state. And we're going to want the frame data, p frame data. And that should be fine. So that's going to give us access to our frame allocator for any allocations we need to do for the frame. I'm also going to do this. I'm not sure we're going to need it yet, but I want to create it in here anyways. We're going to say frame prepare. So the difference between these being is I'm thinking that we update the animation state here, and then any updates that we need to do to the SSBO, or the storage buffer, is done here, just to sort of separate those two. So this is sort of where the general state update happens, and then this is where stuff gets uploaded to the GPU for the draw calls that will come in the next phase of the application's lifecycle. Let's see. Same here for generic data. Yeah, that's pretty much, I'm trying to make that the only place I use it. I'm trying to get rid of void pointers otherwise. I'm always doing dingus-oriented program. Seems to be my preferred way to program now. Yeah, I mean, I do it on stream all the time, so you fit right in here. For sure. Trying to build some utils that include some generic containers and allocators. Yeah, so those are the types of places where you use void pointers. For sure. Allocators is a great idea. Containers, I try to avoid generic stuff. Use case is going to tell you a lot about which parts of a container you need. Like a generic hash table is often much worse than a specific one. I have figured that out as well. I used to have a generic one. Now I just have a straight up one that I just use for very limited things. Does the frame data include frame time like delta time, but also residual, since you're going to need that for blending unless you just cap the update to frame rate? Yeah, so that's the other reason I've split these two up. Is we do have updates are on a separate, like a fixed interval. So those happen 60 times a second, versus our actual render frames can happen either less or more often than that. And so, that's the reason that this is there. But the frame data does include a couple things. Right now, it contains some statistics, which is I'm probably going to wind up taking out of here. Our frame allocator, which is basically just a linear allocator that gets reset every single frame. And then the application frame data, which is like the game code specific stuff that we need per frame. Our game time and our delta time are actually stored in a separate timeline system that I have, which I'm thinking about deprecating and just rolling back to putting it in frame data, quite honestly. But we actually have a separate system for that so that we can declare multiple timelines that go at different scales and different stuff like that, but I'm not so sure I'm going to need it. So I may be moving that stuff back into frame data. But yeah, it's basically, the kind of things that you would need access to every frame, that we could just kind of pass from the core engine all the way down. That being said, though, I do try to keep it somewhat light because we do pass it around a lot. Okay. So, animation config. I feel like that's probably going to include a lot of stuff that's going to come from file formats and stuff like that. So I'm going to put a to-do on this, and we're going to come back to it. Because I don't feel like we're going to need that right now. I should probably also export the appropriate systems. So, or the appropriate functions here. So let's do timescale, animation create and destroy. Yeah, and all of those ones. Okay, so these are only going to ever be called from engine code, so they do not need to be exported. I'm trying to think if we need anything else at this level or not. Because essentially all this is going to do is all of the updates that happen on all of these various tracks and all this other stuff is ultimately going to get all blended down and jammed into these individual shader datas for the animation, per animation, right? All of those things are going to be basically blended down into a flat list of transforms, and that's what's going to be used in the shader, right? So, I don't think there's too much we need beyond this in terms of our initial design. I think this is going to cover us mostly. Thank you for the follow. I appreciate that. Welcome. Let's see. Albeit rare, it's still a pain to find, copy, and paste really old code. Yeah, especially when your style has changed. Which is why I almost never do that. Sometimes I'll reference something that I wrote in the past, but I'll completely rewrite it. Just because, everybody looks at the code that they wrote 6 months or a year ago and goes, that's rubbish. I can do it better now. All right. So do we have everything as far as our structures that we need? I think minus this, I think we might actually have everything we need. So let's take all of these and we'll go over to the C file. And we'll get these in here and at least kind of scaffold them out so that we don't have to do that later. And we don't need these in here now. All right, and then suppose I could have macroed this, but I'm almost done at this point. All right, so so the animation system initialize, from the animation system config, we are going to take these states, and we're going to do max animations equals config max animations, and then we'll do states animations equals kalloc c array. And so that type is going to be animation data, and that's going to be states max animations. Oops. And then states, let's see. Actually, that's the only thing we need in here because we already have this guy set up. Okay, so I don't think this is quite what we need anymore, though. What we really need is the animation shader data times. So let's do actually, yeah, we do need animation shader data times config, or I guess states max animations, right? So that is going to be the size of our storage buffer. That should hold everything we need. Okay, so that should be fine. And then I guess next we will need to, we're already doing destruction of that, so that should be fine. Okay, so next I guess we have to just do, let's see. Is there anything within these animations that needs to be no, we're going to have to create these. We're going to have to stand these up as the animations actually come in. I don't think there's anything we can pre-initialize here. The only thing I can do, we do need some way, because when we go to actually create an animation, we're going to need to look for a quote-unquote free slot in this array. And so we need some way to sort of identify, what makes this particular thing free. And I'm thinking the animation count. The animation count being 0, which is the default state anyway, will mean that that's free. And then when we tear those down, we'll just have to make absolute sure to, destroy all these arrays, tear it down, set that to 0, or honestly 0 out the struct, and go from there. So I think there's not any sort of pre-initialization we have to do for all of those. I think we are good on that front. So when we do animation creates, I suppose that's probably the next one we can at least kind of start feeling out. We can do U16, or I guess we'll do K animation actually. Anim equals invalid, oops, K animation invalid, isn't it? Yeah, there it is. And so what we'll do is we'll do for U16 I equals 0, I is less than state max animations plus I. And then we'll do if state animations sub I animation counts equals 0. And I could do not there, I realize that, but this is a little bit more explicit in terms of how it's used, I feel. Then all we need to do is go ahead and set anim equal to I. And we can actually just trim that down to a U8. I suppose... Oh, max animations is a U32. That's no bueno. Let's change that really quickly. U8. Okay. I suppose this could also be a U8 as well. And I don't have to do this. Okay. Then we'll break. So if at this point we have iterated through the entire array and we've not actually updated this, that's an issue. So I'm going to do a k-assert debug. And I'm just going to do assert that animation is not equal to k animation invalid. And then at this point we can do all of our initialization and then return anim, right? So we can do to do init based on anim config, etc. Right? That should probably actually be a fix me. Okay. Relatively straightforward stuff. For an animation destroy, we'll do a if animation is not equal to k animation invalid. Then we'll go ahead and say state animations sub animation. And actually we'll just go ahead and grab a convenience pointer to that. So we'll say animation data is equal to that. We need the address of that actually. And then obviously we'll have to do, k free C array, and we can do data. Let's see, I guess we should probably do bone transforms and skeleton. Do we have a track count actually? Animation track. Animation count, I guess is what we were calling that. That should probably be track count. All right, anyway. So we're going to free bone transforms, right? So that's of type mat4. And then the count is going to be data bone count. Just freeing up stuff like that. And then k-free type C array data. What did I say? Active. We should probably do active animation states. So that's going to be animation state. And then data active and count. And then k-free C array data. Probably also need to we'll do tracks first, I guess. Animation track. And then data animation count, which I need to rename to track count. Okay. And then of course, we do K0. Oops, K0 memory. The block is going to be data. And the size is going to be size of animation data, right? And so in here we'll have data. Let's see. Skeleton. And then we have bones and transforms, right? Which is, I think we have, yeah, the bone count, right? So we'll have to do, I guess we'll do it here. So we'll do skeleton bones. Or actually, I guess we'll do transforms since this is already map 4, right? That's going to be bone count, and then we'll do skeleton bones. This is going to be animation bone count, right? All right, I think that's all the data that we need to do for that. So whenever we destroy an animation, that's just how we do that. We zero it out, and that gives us a proper clean slate for something else to come in and take and use that slot. Let's see. Oh, this should be, wait. Yeah, this should be track count, right? Because we can't have any trackless animations. So that's going to be our sort of zero equals free slot, because we cannot have animations with no tracks. Obviously, I will improve the comments once we have all this figured out. Let's see. Need to get going. Have a good night, everyone. All right. See you later, Psycode. Thanks for stopping by. Appreciate it. Have a good one. Is it Phi? Not sure if I'm pronouncing that correct. Didn't know you stream on Saturday too. It's Friday night for me, but yeah, I guess it's close to Saturday. I normally don't. This is a makeup stream because I missed one earlier in the week. So I'm just kind of doing an extra stream tonight. But yeah, I normally don't. Maybe if things change, that can be a thing I do in the future too, but for right now, probably not. All right. I don't feel like we have to do anything with the storage buffer for either one of these things because the update will automatically handle that for us. So that I'm not going to worry about too much. Some of these other things like state types of stuff, we could probably, I probably need to make some way to store timescale, right? So let's have a F32 timescale, right? And up here, we can do state timescale equals 1.0. And then here, this one is just as easy as just setting that. Simple enough. All right. So the rest of these functions we'll have to fill out in the future once we figure out exactly how we want our data to work. I think probably the next thing that we're going to have to do is start figuring out, probably this update loop is going to be the thing that we're going to want to figure out next. Because that is ultimately what is going to update our transforms that's going to be fed to the shaders that we're going to then use. Or it's going to be fed to our storage buffer, which will then be used by the shaders. So that's probably going to be the next thing that we're going to do. And I'm just going to put a left off here. So that I know where I left off. And once we have that set up and once we have it figured out how exactly all of this stuff is going to be used, then I think it makes sense to come back in here and create all of these smaller functions. But for now, I think it makes sense to probably tackle this next because that's going to be the biggest bit of usage code. Followed by our frame prepare, which is going to be uploading to the GPU. So I'll just put that here as well. Upload to the storage buffer. All right. I think that's going to do it. I think that's going to do it for tonight. All right. So I'm actually getting a little bit tired. I had a little bit of a long day today, and my voice, I can tell, is starting to get stressed again. So I'm still recovering from earlier this week, and I think my voice is starting to give out on me. So I think I'm going to have to end the stream now. I was hoping to go a little bit later, but I think I'm going to err on the side of caution and not do that. So with that said, I'm going to find somebody to raid. And while I do that, I just want to say thank you to all of you who showed up and interacted, and helped me, figure some of this stuff out. I really appreciate it. And I know who we're going to raid, actually. We're going to raid Els Dragoon because they're still awake. So we're going to go check and see what they're up to. And yeah, we will... let's see. Did it actually... start the raid? I can't tell if it actually started it or not. All right, I'm going to click it again. Oh, I think did they click off? No, they didn't. They're here. Oh, okay. I guess the UI is flipping out. Okay. Alrighty. So we will raid them, and they are making an NES game using 6502 assembly. So we're going to go see what they're up to. And thank you guys again. If you haven't already, I would really appreciate a follow and or subscribe on the YouTube side. I appreciate you guys being here, trying to grow the channel and all that. And yeah, I guess I'll see you guys on the next one. Oh, that madman. Yeah, it's actually a team. Yeah. So yeah, thank you guys for being here, and hopefully it should kick over here in a second. I don't know why the there we go. All right. See